and environmental isolation play in sustaining such a vast rotating disk? The answers lie in observations that blend radio maps of hydrogen distribution, optical studies of stellar populations, and simulations that push models to the extremes of their parameters. The detailed mapping of UGC 2885's neutral hydrogen has revealed a massive, extended reservoir that stretches well beyond its stellar disk. This immense supply of gas not only acts as raw material for future star formation but also serves as a tracer for the galaxy's gravitational potential. Its rotation curve remains flat and extended, a signature that dark matter plays a significant role in maintaining the galaxy's stability across such vast scales. The inferred dark matter halo is colossal, one of the most massive associated with a disk galaxy, yet its distribution must be finely tuned to allow the disk to remain thin and ordered. Spectroscopic studies across the disk show a surprisingly uniform metallicity gradient, with only a gentle decline from the center to the outskirts. This suggests that UGC 2885 has not experienced major mergers or disruptive inflows, which would typically stir up the chemical distribution. Instead, a gradual enrichment process seems to dominate, powered by generations of steady star formation recycling material into the interstellar medium. Such chemical regularity hints at a deep equilibrium state, where the galaxy evolves under self-regulating processes. Deep field imaging and high-resolution photometry have failed to uncover tidal streams or stellar substructures that would indicate recent accretion events. This absence of fossil signatures supports the hypothesis that UGC 2885 has followed a path of relative isolation. Its environment is unusually quiet, residing in a low-density region where major interactions are rare. This cosmic solitude could be the key ingredient that allowed such a giant to form and remain undisturbed for billions of years. Computer simulations that attempt to replicate UGC 2885's properties are still grappling with the challenge of reproducing its enormous mass without inducing bar instabilities, disk warping, or morphological transformation into a lenticular or elliptical structure. Theoretical models must account for the complex interplay between cooling gas, feedback from stellar winds and supernovae, angular momentum transport, and the influence of dark matter halos. UGC 2885 thus becomes a testbed for refining models of galaxy evolution, particularly in the high-mass, high-angular momentum regime. Its existence also challenges the empirical scaling relations that define the galaxy population, such as the Tully-Fisher relation, which links rotational velocity to luminosity. UGC 2885 sits at the extreme high end of these relations, and its outlier status offers a valuable data point to probe the limits of these correlations and their physical underpinnings. Precision measurements of its kinematics help recalibrate these relationships and offer insight into the universality, or flexibility, of galactic laws. Yet perhaps the most intriguing aspect of UGC 2885 is not simply its scale, but the quiet mystery of its success. How, in a universe where gravity so often conspires toward chaos, shattering galaxies in collisions, triggering starbursts, feeding violent black holes, did this spiral giant survive and thrive with such grace? There is no evidence of a central active galactic nucleus, no quasar-like blaze from a feeding supermassive black hole. Its core is subdued, its heart seemingly asleep. This silence raises a profound question: did UGC 2885 ever ignite with the fury of an active nucleus, or has it always existed as a gentle colossus, avoiding the violent feedback that typically quenches star formation in massive galaxies? If so, it suggests a possible divergence in the evolutionary fate of galactic giants, between those that awaken their central monsters and those that remain in quiet slumber. Moreover, its angular momentum is remarkably well preserved. In most massive galaxies, interactions, mergers, and internal torques tend to redistribute angular momentum, thickening the disk and fostering bulge formation. Yet UGC 2885 retains a clean, extended disk with minimal bulge growth, an architectural marvel that seems to defy the statistical trends. Could this be a glimpse of what the Milky Way might become in a far future era, if left alone to evolve in peace? Simulations of isolated halos with high spin parameters have begun to hint at the conditions necessary to build such a structure. These rare halos, rotating with just the right amount of angular momentum, can stabilize enormous disks without collapsing inward. The baryonic matter cools slowly, settling into elegant spirals instead of fragmenting into clumps. In this context, UGC 2885 might not be an anomaly, but a beacon, a rare but natural endpoint for certain initial conditions set in the early universe. What remains unknown is how such a galaxy maintained this delicate trajectory for over 10 billion years. Cosmic time is unforgiving. Galaxies are born into turbulence, bombarded by satellites, swept by filaments of inflowing gas, caught in gravitational eddies and flows. For UGC 2885 to emerge unscathed, massive, ordered, and rotationally supported, implies a remarkable convergence of luck and physics. Or perhaps, a rule yet unrecognized, a pattern overlooked in the chaos. And then there's the question of what comes next. Will UGC 2885 continue this calm expansion indefinitely, or are we witnessing it in a rare, transitional phase? Could it be on the cusp of awakening, its central black hole slowly stirring, the equilibrium beginning to tilt? Is there a vast inflow of gas gathering in the outskirts, soon to trigger a new epoch of star formation, or a collapse into central activity? Or has it already passed its golden age, now gliding quietly into senescence, its vast arms like the fading ripples of a once mighty wave? In every pixel of its image, in every data point of its spectrum, UGC 2885 whispers of an untold galactic biography. Its size is not just a matter of measurement, it is a challenge to theory, a monument to cosmic patience, and perhaps a hint at how the universe can build giants not with fire and fury, but with silence and time. Astronomers now look at UGC 2885 not merely as a subject of classification, but as a cosmic relic, one that may hold the keys to understanding the upper limits of disk galaxy formation. In a universe where most spirals are modest, and giants are often disordered or transformed into ellipticals, UGC 2885 stands as a contradiction, a massive spiral that retained its identity, seemingly untouched by the violence that defines cosmic evolution. Deep radio surveys continue to probe its cold gas halo, revealing an envelope so vast it challenges the very definition of the galactic boundary. Some estimates suggest its hydrogen halo extends well beyond the optical disk, possibly over 1 million light-years across, blurring the line between galaxy and intergalactic medium. This immense reservoir acts not only as a fuel tank for future star formation, but also as a shield, slowing the accretion of external material and buffering the galaxy against disruptive gravitational events. High-precision photometry has begun to resolve stellar populations across its disk, uncovering subtle differences in age, metallicity, and kinematics. The inner regions reveal older, redder stars, remnants of an early epoch of rapid star formation, while the outer arms display younger, bluer populations, still in the act of forming from pristine hydrogen. This radial gradient tells a story of inside-out growth, where the galaxy expanded like a ripple in still water, slowly accumulating mass over cosmic time without ever losing its symmetry. And still, questions multiply. Why is its star formation efficiency so low, given the abundance of gas? Are magnetic fields playing a stronger role than expected, stabilizing the disk against collapse? Could UGC 2885 be part of a new class of ultramassive, low-activity spirals, cosmic hibernators that hoard their fuel rather than burning it in starbursts? Or is it simply an outlier, a galactic anomaly born from initial conditions so rare that we may never observe another like it? Telescopes like JWST and future observatories promise to peel back even more layers. With deeper infrared imaging, astronomers hope to trace the faintest stellar structures in its outskirts, looking for warps, flares, or low-density tidal streams that may hint at past interactions invisible in current data. Spectroscopy at unprecedented resolution may uncover the subtle fingerprints of past mergers, buried deep in the orbits of stars or the metallicity of star clusters. Gravitational lensing studies could help refine its dark matter profile, testing whether its halo is indeed the unusually massive, smooth, and extended structure that current models predict. And beneath it all, the gravitational hum of its unseen heart, likely a supermassive black hole, remains quiet. Not dormant, but patient. Waiting. There is something almost eerie in that stillness. In a galaxy so grand, so massive, so richly supplied with gas, we might expect chaos. But UGC 2885 offers another vision, that the universe, under rare and precise conditions, can sculpt order from abundance. That growth need not be violent. That a giant can rise not through conquest, but through harmony. Perhaps, then, UGC 2885 is not just a record of what galaxies can become, it is a vision of what they might have been, had the cosmos chosen a quieter path. Such reflections cast UGC 2885 not only as an astrophysical subject, but as a philosophical one, a quiet sentinel in the dark, defying the odds, bending the expected arc of galactic destiny. While the cosmos is often viewed through the lens of violence, supernovae, mergers, jets, and black hole eruptions, this galaxy invites another narrative, one of persistence, balance, and sublime restraint. Its spiral arms, vast and unwound, rotate in almost hypnotic stability, as if tracing invisible pathways written by the early universe. These arms, extending over 400,000 light-years from the core, may act as cosmic memory, echoes of tidal rhythms, density waves that have gently moved outward for eons, organizing matter into stellar generations. Within them, star formation proceeds with measured calm, lacking the bursts and turbulence found in smaller, more chaotic systems. Here, stars are born not in firestorms but in quiet nurseries, embedded within vast molecular clouds that drift lazily through the disk. The efficiency is low, the pace deliberate, as if the galaxy has all the time in the universe. And perhaps it does. Because UGC 2885 is not consuming itself in youthful exuberance, it is pacing itself, conserving fuel for a longer story. Some researchers speculate that this galaxy could serve as a bridge in our understanding of cosmic transition, from youthful, active spiral galaxies to mature, passive systems. Most massive galaxies eventually lose their disks, forming bulges and halos through mergers. But UGC 2885 remains intact. It hints at the possibility of a spiral aging with dignity, never collapsing into chaos or transforming into an elliptical relic. Could it represent an evolutionary fork? One where galaxies, under certain cosmic alignments, avoid both starburst burnout and merger-driven collapse. In this scenario, UGC 2885 is not an accident, but an alternate conclusion, a whisper of what galactic evolution might be in a universe governed by delicacy as much as destruction. It is possible that the galaxy's size protects it. Its vastness creates a kind of internal inertia, buffering against disruptive feedback loops that plague smaller systems. Stellar winds and supernovae, which can destabilize dwarf galaxies or trigger runaway bursts in mid-size spirals, dissipate harmlessly within the enormous volume of UGC 2885. Energy spreads thin. Turbulence fades before it can spread. Gravity reasserts order. Even more fascinating are the implications for galactic habitability. A galaxy like UGC 2885, with its long periods of calm, slow-burning stars, and wide buffer zones away from active nuclei, may offer extraordinary potential for life. If intelligent civilizations were to arise in its outer arms, they might gaze inward upon their galaxy's grandeur and find it stable, predictable, almost serenely eternal. A cosmic cradle where time moves slowly, and danger sleeps. And so UGC 2885 becomes more than an astrophysical curiosity. It becomes a symbol of potential, a vision of longevity, peace, and silent strength in a universe often defined by the opposite. It reminds us that the cosmos is vast enough to allow exceptions, and rich enough to craft structures that are not just functional, but majestic. But this tale may not be over. Observations continue, ever deeper, ever finer. Each photon collected from this spiral giant may carry a clue. Somewhere within those quiet arms or that vast, gas-rich halo may lie the final answer to how such a giant was born, and whether it is truly alone in its kind. Or perhaps, scattered across the darkness, there are other titans still hidden. Other Godzilla galaxies waiting to be seen. The search for such titans has now become a quiet obsession among astronomers, an unspoken hope that UGC 2885 is not a lone outlier, but rather the first visible peak of a hidden population of ultramassive, undisturbed spirals. If they exist, they are rare, lurking in the underexplored outskirts of the cosmic web, far from the bustling centers of galactic clusters. Their isolation would be both their birthplace and their shield, allowing them to grow without disruption. Future sky surveys, deep, wide, and multi-wavelength, may reveal their presence. Instruments like the Vera C. Rubin Observatory will map the faintest structures in the night sky with unprecedented sensitivity, capable of detecting ghostly disks, sprawling hydrogen halos, and subtle spiral arms that current surveys miss. The James Webb Space Telescope, peering into the infrared, may glimpse their ancient stars and star-forming regions cloaked in dust. And radio arrays like the Square Kilometre Array will trace their cold gas skeletons across millions of light-years, outlining galactic giants by their invisible breath. But even as we prepare to detect their kin, UGC 2885 remains the benchmark, a solitary monument against which others will be measured. Every detail of its rotation curve, every fluctuation in its gas density, every metallicity gradient across its disk becomes part of a growing library of what may be possible. Not just astrophysically, but cosmologically. They tell us about the universe. Scale is improbable. That order, when it appears in of chaos, is not merely beautiful, it reveals the constraints within which galaxies state, and how complexity and collapse. Crystals. Relations not just for violence and variety, but for elegance. To explain not only how galaxies burn bright and die, angular momentum must be preserved, how stars be tamed. UGC 2885 becomes not just a test of physics, but a philosophy. Can the laws of Earth allow such perfection? None. Even its name, Godzilla Galaxy, feels paradoxical. Godzilla, the icon of destruction, now applied to a creature of cosmic harmony. But perhaps that's the deeper irony. In a universe filled with fire and collapse, perhaps survival is the most extraordinary act of all. And so UGC 2885 rotates on, alone but not forgotten. A spiral without scars. A giant without fury. A question without a final answer. Not yet. Not yet, because UGC 2885 continues to pull at the edges of our understanding, like gravity itself bending the straight lines of theory. With every observation, it reminds us that the universe is not only governed by destruction, but by patience. That in the grand contest between chaos and order, there are places, rare, hidden, enormous, where order has quietly won. And still, its mass is not its only mystery. The rate at which it spins, the smoothness of its disk, the unexpected coldness of its gas, all suggest a hidden orchestration, as if the galaxy has maintained a delicate internal equilibrium for billions of years. Gravity pulls inward, pressure pushes outward, rotation balances the two. But on this scale, hundreds of thousands of light-years, the stability defies not just observation, but expectation. Some speculate about ancient events that may have set UGC 2885 on this quiet trajectory. Was it born in a region of the early universe with unusually low density, allowing it to evolve in near-total solitude? Did it receive a cosmic inheritance, a particularly massive dark matter halo with just the right spin, shielding it from galactic predators and giving it room to breathe? Did it once have siblings, now consumed or dispersed, leaving it as the last survivor of a long-lost filament? Or is it older than we think, not in age, but in cosmic maturity? Could UGC 2885 represent a kind of accelerated galactic evolution, where the usual timescales of star formation and disk growth unfolded faster, more cleanly, more efficiently, then slowed again, allowing the structure to crystallize in place? A galaxy that grew not through disruption, but through discipline. It might even offer insights into the deep interplay between baryonic matter and dark matter, the strange, unseen scaffolding that shapes galaxies from behind a cosmic veil. UGC 2885's halo may be unusually smooth, unusually spherical, unusually cold. Perhaps its very existence hints at variations in the dark sector, new physics yet to be found, written not in particle collisions, but in the slow dance of spiral arms across a million light-years. Even now, long after it formed, UGC 2885 remains astonishingly quiet. It emits no gravitational waves, no bursts of X-ray radiation, no signs of recent upheaval. It does not rage, it endures. And that endurance may become its legacy. For while most galaxies live brief, brilliant lives, flaring with activity, then fading, UGC 2885 seems designed for the long game. It may continue rotating calmly for trillions of years, forming stars slowly, fading gently, drifting farther from the rest of the universe as dark energy stretches space. Long after the last quasar dies, long after the spiral arms of the Milky Way blur into a spheroid, UGC 2885 may still be there, dimmer, quieter, colder, but intact. A fossil of harmony. A relic of balance. A monument to what the cosmos can build when it chooses not war, but wisdom. And in that distant future, when the stars of younger galaxies have long since burned out, when interstellar gas has been consumed or dispersed, and when the universe itself has grown vast and empty, UGC 2885 may remain a lighthouse in the dark, its spiral arms faded, its starbirth slowed to a whisper, but its structure still recognizable, still whole. Imagine such a time, trillions of years from now, in an era of cosmic silence, where galaxies have merged into red ellipsoids or evaporated into the void, and black holes dominate the landscape of space. Amid this dying universe, UGC 2885 may still quietly spin, like a great watch wound by some forgotten hand. The stars within its disk may cool to embers. Its gas may freeze into molecular clouds too diffuse to collapse. But its form, its beautiful, improbable spiral form, may persist like a memory the cosmos cannot quite erase. And if there is life, somewhere within it, perhaps clinging to a dim red dwarf in its outer rim, it may one day look inward, trying to make sense of the galaxy's enormity. Perhaps they will not remember the Milky Way or Andromeda or the clusters that once peppered the sky. But they will have this, a galaxy vast beyond comprehension, yet gentle enough to harbor stillness. A Godzilla not of destruction, but of survival. For now, though, we observe. We map. We simulate. We question. We study the gravitational shear in its halo, hoping to detect deviations from cold dark matter predictions. We analyze the scale length of its disk, comparing it to formation models across redshifts. We run simulations with high spin parameters and low merger rates, seeing if the algorithms can, even once, recreate what the universe sculpted naturally. And always, we return to the same astonishment: UGC 2885 should not exist in this form. But it does. And so it whispers, no, declares, that there are still exceptions in a universe of rules. Still islands of grace in oceans of entropy. It has become a kind of cosmic koan, massive, yet unbroken, ancient, yet star-forming, isolated, yet complete. A riddle etched across 800,000 light-years of starlight. And in that riddle lies possibility. Because if such a galaxy can exist once, perhaps it can exist again. Or already does, unseen. And if nature can assemble such grandeur not through violence, but through quiet coherence, perhaps our models are incomplete not in their equations, but in their assumptions. Perhaps we have underestimated what the cosmos can build when it chooses to be patient. UGC 2885 is a monument not only to astrophysics, but to all. To the notion that not all giants must roar. Some simply are. And in their being, they rewrite what we thought we knew. And perhaps this is the true legacy of UGC 2885, not merely a record breaker, not just a cosmic anomaly, but a challenge. A challenge to our understanding of how galaxies grow, of what the universe permits, and of what it prefers. For if the cosmos has an aesthetic, if it sometimes chooses symmetry over chaos, silence over spectacle, then UGC 2885 is its masterpiece. Its disk, unmarred by violence, is a canvas painted in slow motion. Each arm, stretched wide into the void, curves not just with gravity, but with purpose. Each star, whether ancient or newborn, plays its role in a choreography so vast that it escapes the imagination. And somewhere in its quiet heart, perhaps in the very stillness of its core, lies the echo of cosmic intent. There is poetry here, written in hydrogen and dust, in spin and silence. It is a kind of galactic haiku, enormous, elegant, enduring. And for scientists, it is a call to look deeper. To revisit assumptions long held. To imagine galactic formation not solely as a process of competition and collision, but as one of balance, where isolation, angular momentum, and environmental quietude can conspire to create not just survival,